Okay, so welcome everyone to this session, which is about how Eclipse can be customized and extended using JavaScript. So my name is Mattias Mohlin.
And my name is Elena Strabykina. We are working at Cell Technologies platforms divisions, working on modeling tools that we are developing on top of Eclipse. And today we have this content to share with you.
Yeah, so we will look at various ways we have in the past customized Eclipse, and in particular JavaScript, of course, and also look a bit on the state of JavaScript development in Eclipse, and then look at how we have used JavaScript in one particular customization scenario for an industrial context. One of our customers was driving, and we'll run a demo of that later also. So the first question to start with is, of course, why do we need to think about another way of customizing Eclipse than writing Java plugins? Because that has always been the traditional way of customizing Eclipse. But it has turned out that many of our customers think the threshold is a bit too high to start writing a Java plugin if you want to customize Eclipse. And so for many years ago, we did something called a pluglet, which basically is a simplified plugin. It's a small Java application that you can use for making minor extensions to the Eclipse workbench. And the pluglet source code is basically Java that you put in a pluglet project. And the difference compared to a normal plugin is that it executes in the same instance as where you develop the plugins, which is similar to a script language. And it works by having JDK compile the pluglet source code into class files that then are immediately loaded into the running workbench. And of course, since this is Java, it has access to all Java APIs provided by Eclipse plugins, which is nice. And it's a little bit easier to get started developing customization in this way. But it has turned out that there are some drawbacks also. For example, if you want to debug your pluglet, you still need another Eclipse instance running to debug it. There is also no really good solution for deploying these within our organizations. There are nothing like P2 update sites that can be used for deploying these pluglets. And we have found that even if this has been available in our products for many years, it has only been used for quite few situations, quite few customers. So a couple of years ago, we started to look at JavaScript, which, as I'm sure you all know, is a very increasingly popular language, in particular since it's used a lot in web development, traditionally in the client side, but now with Node.js also on the server side. And we found this statistics from some website where they looked at most pull requests in 2017 from GitHub, where actually JavaScript projects are the vast majority of projects. So it shows that this is actually a very actively used language. And it has some really nice characteristics like it's simple and fast, it has a familiar syntax, and it's single-threaded, which also is a good thing often for our customers at least. And the real deal breaker here was in Java 8 when the Nashorn engine came that replaced the previous open source engine that was called Rhino. So this allows JavaScript programs now to be run both from the command line using a tool called JJS, but also from within Java program. And it works by translating JavaScript into Java bytecode so that it can run on the JVM, which is a difference compared to Rhino, and it actually gives a much better performance. And initially in Java 8, there was only support for ECMAScript 5.1, but in Java 9 now it is claimed that ECMAScript 6 is almost completely supported. And it has been designed to have excellent interoperability with Java, so you can mix and match Java and JavaScript. And therefore it's a natural question to ask these days, why not allow Eclipse to be customized using JavaScript as an alternative to writing Java plugins? So when looking at JavaScript for customization, of course it becomes important that Eclipse has good support for editing and working with JavaScript. And there is, of course, basic support for JavaScript in Eclipse using the JSDT project, but it doesn't have any specific knowledge about Nashorn. Also, we must admit that this is not the leading JavaScript tool on the market. If you go to a web developer, the chances are very small that they would use Eclipse with JSDT. They would use something else. And the big problem is that it's not easy to debug JavaScript in Eclipse. It might be possible in some tweaked way, but other IDEs like NetBeans make this very easy. And I think that is something that Eclipse needs to look at. There is support for testing now from script. There are functional testing using JUnits, and there is something called Spock, where you can mock out functions not available in Nashorn. But I think our conclusion here is that we really would like to have a better support for JavaScript within Eclipse.
So before running the demo, how we did the customization itself, most of you who used the Nashorn before knows that, but for those who not, this is a brief introduction. That Nashorn JavaScript engine allows you very easily to mix the Java code and the JavaScript code. And for instance, if you have created your JavaScript customization, the direct way in 2 lines how you can evaluate this JavaScript is initialize this engine and call eval by providing their JavaScript text or by pointing to by providing the file reader pointing to your JavaScript file. And then you can play with that, invoking the functions that you defined in the JavaScript and providing their Java objects as the arguments. And then when you are developing the JavaScript and you want to easily access the methods from the Java classes, you can play with the bindings. So there are different scopes, the engine scope or the global scope. It depends on how you want to define this naming, and you can bind the name with the Java object. And after that, it's really easy to access these methods when you start to write your JavaScript customization. So it makes really easier and does not require really deep understanding of how this works. So there is nice ways to do it the vice versa. So once you're writing the JavaScript, you can not only initialize their Java classes and access their static methods, but you can basically virtually do anything with that. And for instance, you can extend the Java classes using the Java extend mechanism. This is something that we used when we wanted to override some functions from JavaScript that we used in Java. And after that, you can create these classes and then just call your customization from it. And if we are looking on the ways how this JavaScript can be evaluated from the Java code, we used basically 2 approaches. One approach is the direct one that you call eval, and the JavaScript Nashorn engine starts to work with the JavaScript. And another one is if you, for instance, decided to implement your own JavaScript editor, or you want to have some syntax checks according to your customization, you would like to use so-called precompiled scripts. So in Nashorn, compared to Rhino, there is a way that you can precompile those JavaScripts by casting their engine to compilable interface and just invoking compile and eval. After that, you can repetitive invoke this precompiled scripts with the different data and could influence the performance if you have many invocations of the evaluated JavaScript. So I think this is all you need to know if you want just to quickly start to customize it.
Yes, and also one important aspect, of course, if you use JavaScript customization is that you have a means to document your APIs. So for Java, we have used JavaDoc, of course, a very long time. But what to do for JavaScript? And if you don't document your extensibility APIs, no one will be able to use them. And for a language like JavaScript that is dynamically typed, I would argue that it's even more important that you have well-documented APIs. So that you specify, for example, expected values for function arguments, and that the meaning of object properties are clearly documented. And there is a tool called JSDoc, which is rather similar to JavaDoc. You can see in the screenshot here a bit what you can write to as comments on your JavaScript. So basically it's very similar to JavaDoc, where you use annotations. And in this example, we can see that we document parameters for a function and also provide an example to the user how they should use the API. And then JSDoc is a command line tool that can take this input and produce nice looking web pages that you can include in your documentation. And yeah, since it's a command line tool, it's also very easy to integrate into Ant-based builds, which we have used. So now, before we look into our practical application of JavaScript, I need to tell you a little bit about our Eclipse-based product, so you know the context here. So our product is called Rational Software Architect Real-Time Edition, and it's basically an extension to Eclipse that allows developers to develop real-time applications in C++ using visual modeling. And a very, very simple high-level overview of what the tool does is shown in this picture. So the user develops code using CDT, as usual, C++ and hero files. Then they also create models, which is mostly state machines and other similar diagrams in UML. And those two sources, the code and the model, goes into RSART, or a model compiler component that compiles that into C++ code, which then is compiled into executables or libraries. And one challenge that our users have is that they often need to build multiple versions of their applications from the same modeling code. There could be many reasons, but for example, there could be different target platforms they need to target, different build tools they need to use in different situations. Sometimes they may need to turn on certain build flags like debug or non-debug. So basically, lots of things can be different when they want to build their applications. And our traditional solution has been to provide them with a way to specify everything in a configuration file, where you can specify exactly how should the model be translated to code, how should it be compiled, how should it be built, and so on. But of course, you can imagine with all those parameters that can be different, the combinations of becomes like an explosion of number of combinations. So customers have had to maintain thousands of these configurations files, and it's really cumbersome to do. So what we came up with then was that we would like them to be able to use JavaScript instead as a way to customize the build process, and we call that build variants. And it's actually a customization on two levels. It's both helping the user in the user interface to select high-level settings that will translate into the correct build settings, but also, of course, to implement the actual build customization in the batch builds, so that the correct settings will be set depending on what he chooses in the user interface.
Okay, so I think now there is a time for a quick demo, and this is really simplified case, just to make it really simple and understandable how this can be done. So a few words about my workspace in Eclipse. So I have my models here, and just to demonstrate to you, I have their peak computation modeled in two ways using the Madhava and Well's product. So I have one set of their model files that defines my application that computes P. So here I can select and look at their state machine. So there is some code which defines how this P number is computed. So I modeled it in a very simple way. And after that, I know that even this simple application can be built in for different platforms. It already has two variants, so there's two formulas, and probably I would like to have some optimization in terms of my source generation. So I want to generate only those sources that will be compiled afterwards. So I want to save my time a bit. And so I can customize it using the JavaScript, and to do that I'm just installing JS plugin on top that is part of the Eclipse Oxygen currently that I use. And after that I'm looking into my basic configuration file, which defines all the settings, as Mattias mentioned, that specifies how my build will run, that transforms the model to executable code. So we have these files defined in the JavaScript. This is the simplified files with the basic assignments, so there is no expressions or any other JavaScript constructions. So it's quite easy. I think everyone who wants to use it in your projects can write your own customization for it easily. And after that, to make these properties be dynamic using the JavaScript, I would like to go in two ways. First, I would like to specify how my build will be changed in these two variants. So in order to do that, I create the very simple JavaScript file. So just a function. It could be, you know, it could play with any configuration at your case. At my case, it's just replace one capsule with another. It's changing the behavior. And another script is their optimization. It's also very simple right now, setting some flag to true or false based on the user selection. In the real scenarios, of course, it might be a lot of code. And after that, I would also like to customize how the builds will be visible for the user. So in most cases, if you have a large group of the people, they are not really experienced in what you know, compile arguments, what all their build parameters they need to use. They would like to see very simple and understandable interface. And this interface may vary from one project to another project. So this is something we would like to customize. And this also I write on the JavaScript. So I define that I want to have some alternatives, how I want to build my P, and then in my implementation I would like to create the combo box for that. You can, you know, you can play with any forms you like. And once the user selects this alternative, I will invoke this JavaScript customization. Also, I would like to specify the source optimization as a simple alternative to turn it on and off. And I will map it with another build customization JavaScript file. And finally, I would like to specify the target platform. So currently this computer is on Windows and we are running MinGV, so I will use the MinGV settings for their compilation. Then in the user cases, the user invokes build. So here is this dialog that I've just customized. This part of dialog saying that I have actually two alternatives. I have these target platforms available for user and some kind of optimization. So this list really can depend on project, on workspace, or on the wrapper, depending on your scenario. So after that, I press build and waiting so my build variant to generate some code that will be presented here in my workspace. So there are some C++ files generated for this, and I guess it includes all the model elements that I've created before. So after that, I think I will try to run this application. So it computed me the P, the precision, as you see, is not really good with this formula. It uses like 100 iterations, so this is not the point. It's just showing you that this application had one behavior. And then I will try to clean this generated. And then we'll invoke build again. So here I will use another serious to generate it, and I still keep the source optimization flag and the same target platform. I invoke the build. So I think there is, I should go, from this folder in the terminal. We typically don't use this, built-in terminal in Eclipse, but since it's very easy to use during the demo, we decided to try it out. So I will try to print it once again. Yes, and if I look into the generated project right now, you see that the number of sources is not the same as it was before, because I use some optimization and computed only those files that needs to be compiled afterwards. And after that, I can again try to build it. So it uses basically another formula for that with the better precision. So it basically means that having, few hours, you can try with the real sample, and then if you really have a large application industry scale projects with a lot of people involved in the different roles, that requires some customization in different levels, in the UI level, in the build level. You can easily write these simple JavaScript files and use it, in your project or whatever you would like to make the dynamic. So I think we can continue. Yeah.
So to summarize, JavaScript is a popular language, and with Nashorn in Java 8, it has now very well supported. It has good performance and it's easy to use. And we have found that it's very possible and good to customize Eclipse using JavaScript. As Elena said, it has been proven in this industrial context, both for non-UI and UI parts actually. And in particular, we think that JavaScript is a good option when you want dynamic behavior in your customization, a dynamic language. And there is support for JavaScript in Eclipse, but it could be improved, you could say. And in particular, the debugging possibilities could be improved. So with that, I think we have some time for questions. If there is any, yes.
Would it be possible to use TypeScript instead of JavaScript?
I suppose so, but I don't really know what will. I guess then TypeScript needs to compile it to JavaScript before Nashorn can use it. So it would you would have to integrate that somehow within Eclipse. I'm not sure exactly if TypeScript can be launched from. I guess it can be launched from Eclipse. So I would assume it's possible to set it up like that. Yes.
Maybe more tricky than to track the error if there is something wrong.
Yeah, and also I'm not sure that probably means that debugging will be even harder if you want to debug in the TypeScript level. We haven't tried TypeScript yet, but on the other hand.
TypeScript, which provides the source map with JavaScript, so the debug in TypeScript decided just for JavaScript.
Okay.
Source running.
Yeah. Yes.
I was wondering whether you know about a project called EASE, which is used for scripting in the application, especially with Python, and whether you consider interfacing with this tool.
What was the name of that?
EASE.
EASE.
EASE. E-A-S-E.
Okay.
And it's used especially for customizing ID. And you can insert, I know for sure, Python scripts. I'm not sure about JavaScript, but
Okay. Yeah, that sounds interesting. Then.
So maybe there could be contribution to language mobile, but I guess this will be as immediate as with your approach because it relies on global interface.
Yes.
So last week it was announced that, not announced, but claimed that maybe next JDK will drop support for national. Have you considered this issue? Do you have alternatives in mind, or?
I was not aware of that. So what was the reasoning they will drop?
The reasoning is that the people who are currently doing national cannot go as fast to support the JavaScript as the regular JavaScript engine, and they cannot follow the trend. And they say that it's better for them to stop doing it than to keep doing it wrong.
Yeah, of course, that would be a major problem if they drop support. But I think it would be sad since they invested quite a lot with Nashorn.
Yeah. Well, it's immediate. Yeah, it's immediate to them, and it's okay because Nashorn will be a peak.
Yes.
It's really a matter of
yeah. So I guess was that for Java 10 or what? No. Yeah. I have to read up about that.
There was another project which was J2EA. I don't know if you have seen this one. It was about integrating JavaScript with Java. Not as strongly as Nashorn integrated, but it's using it's relying on the V8 engine, and it's doing binding. Maybe it can be an alternative to Nashorn integration.
Yeah, but I guess V8 is maybe supporting it slightly better, slightly later versions and so on. No more questions? Thank you.
Thank you.